So far, we discussed about the electric current. That electric current is the flow of electrons in a metal wire. Now, see, in a conductor, suppose you are having a metal wire as a conductor, free electrons are present here. If these free electrons move in a specific direction, then it's known as electric current. But these free electrons present inside, they are not moving in a specific direction. In fact, when this metal wire is not connected to any source of electricity, then these electrons are moving moving randomly in all directions. But now, if we want to make these electrons flow in a specific direction, we need to create a difference. Let me make you understand by taking an example. Suppose you are having two beakers, beaker A and B, and these two beakers are connected by a pipe. And suppose both beakers are filled with water up to the brim, and the water level is same in both the beakers. Now, if I ask you, is it possible that water will flow from either from beaker A to beaker B or from beaker B to beaker A? Is it possible that water will flow through this pipe? No. Why? Because they have the same level of water. Same happens in a conductor. Number of electrons are equal to the number of electrons here are equal to the number of electrons present here. So equal number of electrons are present at both ends. So electrons will not move. Why would they move? The electrons will not move. Now, if we want to make the electrons move, suppose if we want to make the water move, what we need to do? We need to create a difference of water level, right? Suppose some water is removed from this beaker B. Suppose now the level of water in beaker B is this. It means beaker A has more water and beaker B has less quantity of water. Now what happens? Water will start moving, will start flowing from this beaker A to beaker B, right? Why? Because of difference of water, right? Because the level of water is more here and here it's less, so water will flow from more level to less level. And same difference is created in conductor, so that electrons move from one end to other end. And this difference is created by connecting with a cell or by connecting with a battery. Now, what happens when we connect a conductor to a cell or battery? Let's see. So again, this is a conductor. These are electrons present here randomly. But now when we connected them with the cell, this is the cell, okay, and this is the positive terminal of the cell, and this is negative terminal. Positive end is connected to this end. Negative terminal is connected to this B end, okay. Now, as soon as you connected a battery or you connected a cell here, what happens? These electrons will start moving. They will move in one particular direction. They start moving towards this positive end. Now, why these electrons start moving towards this positive terminal? Because electrons are negatively charged, and negatively charged electrons will always attract positive charges, because unlike charges attract each other. So these electrons start moving. In fact, the electrons present here, they also start moving towards this end. Why? Because negative and negative will repel each other, so they move, they will drift towards this positive end. So it means the electrons will start moving from negative end to positive end, right? And this flow of electrons, this motion of electrons constitutes electric current. And this is how we can get the flow of electric current. So basically, like we create a difference in beaker by removing water from beaker B. Same happens here. We connected with battery and created a difference because of which electrons start moving in one particular direction. And that kind of difference is known as potential difference, which is created by battery here. We'll discuss about the potential difference later. So what does battery actually did? In order to move electrons, battery does some work, right? So as soon as you connected the battery, or you can say cell, to this conductor, electrons start moving in a particular direction. So to get the continuous flow of current between the ends of conductor, we need to maintain a potential difference. And how battery maintains this potential difference? Because of the chemical reactions which are happening inside the cell or in the battery. Due to the chemical reactions, potential difference is maintained between the terminals. And because of that potential difference drives the current in a circuit in which this cell or battery is connected. And this is how we can get the continuous flow of electric current. Now let's talk about the direction of electric current. See, when electricity was invented a long time back, it was known that there are only two types of charges, positive charges and negative charges. But electrons had not been discovered at that time. So electric current was considered to be the flow of positive charges because electrons were not discovered. So they thought that that the electric current is due to the flow of positive charges. And what would be the direction of flow of positive charges? Definitely that will be towards the negative end because positive will attract negative. If we are saying that current is because of positive charges, so it means positive charges are moving towards negative end, like in the opposite direction, in this direction, right? This direction is termed as the conventional direction. So conventional direction of electric current is from positive terminal of a cell to the negative terminal of a cell, or you can say battery. So in our circuit diagram, what happens? We always put the arrows on these connecting wires to show the direction, but to show the direction of conventional current. Okay, so direction of conventional current is from positive terminal to negative terminal. That is why we are showing the direction here in upwards, and here it would be downwards, because the conventional direction is from positive to negative, but the actual direction of the flow of electrons is from negative end to positive end, like this is the actual flow of this is the actual direction of flow of electrons, but the conventional direction is opposite to this, that is from positive to negative. Okay, so basically the actual flow of electrons which constitutes the current is from negative terminal to positive terminal, and that direction is exactly opposite to the direction of conventional current. Now, I told you that it is because of the difference that electrons start moving in a particular direction, and that kind of difference is known as potential difference. So whenever we are applying a source to some conductor, potential difference is maintained, and that potential difference is maintained by battery or by cell. So does the battery do? Battery does some work, because battery has to do a work to move the charges from one point to another. So what is potential difference? That is nothing but the work done to move a unit charge from one point to another point. That means the work that is done by a battery to move the charges from one end to another end, from one point to another end, that work done is known as potential difference. Potential difference is represented, denoted by the symbol V. It's capital. And potential difference is equal to the work done in moving the charge from one point to another. That is work done divided by quantity of charge moved. So potential difference is represented by V. So work done. Work is represented by W. Charge is represented by Q. So V is equal to W by Q. That is, potential difference is equal to work done divided by quantity of charge. So you are getting this formula, right? V is equivalent to W by Q, where W is work done, Q is quantity of charge moved. Now, if we look at the SI unit of potential difference, see, the SI unit for work is joules, and the SI unit of charge is coulombs. Okay, see, so the unit for potential difference would be joule per coulomb, and this is equal to the V. Here it's not potential difference, it is the unit volt. So both potential difference is also represented, denoted by V, and the unit volt is also denoted by the V. So joule per coulomb is equal to the volt. So SI unit of potential difference is volt. Both potential difference and volt is represented by the letter capital V. Okay. So if I ask you to define 1 volt, then 1 volt will be equal to when 1 joule of work is done on moving 1 coulomb charge from one point to the other point, right? So whenever 1 joule of work is done in moving the 1 coulomb charge from one point to another, then our potential difference is said to be equal to 1 volt. So basically these are cells or batteries that maintains the potential difference. As I told you earlier also, that the simplest way to maintain a potential difference between the ends of conductor is to connect them with a cell or a battery, because when you are connecting them with a cell or a battery, that cell or battery maintains the potential difference, and because of that potential difference, flow of current takes place. That means electric current is produced. So you have to maintain the potential difference, and that is maintained by cell, or you can say by battery. Now, potential difference is measured by an instrument that is called voltmeter. This is voltmeter, and this measures the potential difference. This is the representation or the diagram of the voltmeter. You have to represent it by V, and this wire is connected to the positive end, and this wire is connected to the negative end. Okay, so voltmeter has high resistance. See, resistance again word comes in ammeter. You also saw the word resistance, and here it's also resistance. We will discuss it later. And one more thing, voltmeter is always connected in parallels. See, this is the parallel connection of voltmeter. This is our conductor, or you can say wire, and we do not connect it end to end, or we do not connect it in along a side, but we connected it between these 2 points A and B. This is the parallel combination of voltmeter. So voltmeter is always connected in parallel, and voltmeter has high resistance. Okay, yeah, one more thing, voltmeter is having another name, that is potential difference is having another name, that is voltage. So basically voltmeter measures the potential difference, or you can say voltmeter measures the voltage. Okay, now at the end there's one more point written here, that is current always flows from higher potential to lower potential. See, high potential, that is either where high potential is in the positive end or in the negative end. Higher means more, and that is always at the positive end. It means higher potential is the positive end, and lower potential is the negative end. So current always flows from higher potential to lower potential. That is why we show the conventional direction from positive to negative end. But yeah, actual flow of electrons is from negative end to positive end. This was all about the potential difference.